In today's episode, we're going to be talking about what are acids and what is pH.
Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A.
Hello, welcome back. I hope you're well. I hope your chemistry studies and your other studies are going well. In this episode, we're going to be talking about what is acid and particularly what is pH. As we often do, we're going to start with a definition and we're going to define what an acid is. We're going to use the Bronsted-Lowry definition of what an acid is. There are other definitions as well, but this is the one you'll use in A-level chemistry, and most likely, if you're studying elsewhere in the world, please check your syllabus that the Bronsted-Lowry definition is the one that you're using. In this definition, an acid is a substance that can donate a proton. And in passing, let's also mention that in that definition, a base is a substance that can accept a proton. Why a proton? Why not an H plus ion? That's usually what you expect to see when we talk about acids. Well, let's think about it. A hydrogen atom has one proton and one electron. There are also a tiny, tiny proportion of hydrogen atoms that have a neutron or even two neutrons, but there's still one proton and one electron. When our hydrogen becomes an H plus ion, it loses that electron, and therefore what's left? A proton. It's just a proton. So an H plus ion and a proton are the same thing. So when you see proton, think H plus ion. So why is an H plus ion so reactive that that particular ion makes something acidic? It's because it's a proton, it has a 1 plus charge and no electrons. So the surface area of that species, that H plus ion, is tiny. It's just a proton. It's just that tiny nucleus. And I'm sure if you remember back, you know that the nucleus is that tiny point in the center of an atom that is very small compared to the size of even a small atom. Therefore, that 1 plus charge of the proton is spread over just that tiny surface area of the proton. It's not spread over the surface area of an ion that has any electrons, because if there are electrons present, the ion would have a much bigger surface area. So why does that matter? Well, it means that the charge to surface area ratio of a proton is huge compared with that of any other ion that has electrons. So it's not about the size of the charge, it's about the size of the charge to surface area ratio that makes an H plus ion so reactive. Part of that definition was about donating that proton. So what's it donating to? Well, it's very often to the water in the aqueous media that we often have our acid in, or we often do our reaction in. And water molecules accept a proton to become an H3O plus ion or hydronium ion. Okay, so what is pH? In basic terms, pH is a measure of how acidic a mixture, a solution is. That means it's a way of quantifying the concentration of H plus ions in that solution, that mixture. And in fact, the scale was invented because somebody wanted to know the concentration of H plus ions in an industrial process they were doing. In the early 20th century, a chemist called Soren Sorensen, who worked for the Carlsberg Brewing Company, wanted a simpler way of expressing the hydrogen ion concentration, because the process of fermentation with the yeast works much better in a specific range, in a narrow range of hydrogen ion concentration. He wanted to have an easy way of stating the acidity, the hydrogen ion concentration. And he came up with a logarithmic scale, and that is what became pH. And what he came up with is that pH equals the negative log of the hydrogen ion concentration in moles per decimeter cubed. And that log is the log to base 10 that we're referring to here. So pH equals the negative log of the hydrogen ion concentration in moles per decimeter cubed. And at this point, we're going to introduce the concept of strong acids and weak acids. Let's start with strong acids. There are just a few of those, really. These are the well-known acids that you come across, perhaps in the college lab, certainly in textbooks and so on. So sulfuric acid, hydrochloric acid, nitric acid, phosphoric acid are the ones that you will usually come across. There are one or two others too. And they're commonplace because they are strong acids. And what do we mean by strong acid? We mean that every molecule dissociates. That means that when we add HCl to water, every H plus and Cl minus dissociates in the water. We don't have some HCl molecules remaining undissociated. They dissociate into their separate ions, the H plus and the Cl minus. Similarly with nitric acid, HNO3, when we put that into water, every single molecule dissociates into an H plus ion and an NO3 minus ion. Maybe up to this point, that's what you expect acids to do anyway. But actually, there is also weak acids. This is actually most of the acids that we come across. For example, all organic acids are weak acids. Weak acids don't dissociate completely. What we mean by that is that when we put some of a weak acid, for example, ethanoic acid, into water, the vast majority of the molecules don't dissociate. They stay as ethanoic acid complete molecules. A small proportion do dissociate into an H plus and an ethanoate ion. Now, the proportion that does dissociate varies with which acid it is and the temperature. But typically, weak acids dissociate no more than a few percent of the molecules. And for many of them, it's a much smaller proportion that does dissociate. Okay, let's tackle a misconception about strong acids and concentration. A strong acid is one where every molecule of the acid dissociates in water, and that doesn't matter whether we put a tiny bit in, so it's very weakly concentrated, or a lot of that acid into the water, so it's actually highly concentrated. It's still a strong acid even when it's very dilute. A weak acid could be very concentrated or dilute. The concentration doesn't affect whether that's a weak acid or not. Regardless of it being concentrated or dilute, only a small proportion of the weak acid molecules will dissociate into the H plus and the anion when dissolved in water. Okay, let's summarise what we've talked about today. We've defined what an acid is according to Bronsted-Lowry. We said that it's a substance that donates a proton. We also said that a proton is just another way of expressing what an H plus ion is. We also considered that protons, or H plus ions, are as reactive as they are because they have that 1 plus charge over the tiny surface area of a proton and not the bigger surface area of an ion that has electrons. We talked about pH being a logarithmic measure of the hydrogen ion concentration, and we talked about the history of that being invented by an early 20th century chemist to simplify how we talked about H plus ion concentration and acidity in the brewing process. We also talked about the concept of a strong acid and a weak acid, a strong acid being one where all the molecules of that acid will dissociate into H plus and anion, and a weak acid being one where only a small proportion of the molecules will dissociate into H plus ion and anion. And we said don't confuse strong or weak acid with how concentrated or dilute they may be. These are completely unconnected. A strong acid could be concentrated or dilute or somewhere in the middle. It makes no difference to the fact that it's a strong acid. The molecules will still dissociate completely. Likewise, a weak acid is still a weak acid, whether it's very concentrated, very dilute, or somewhere in between. Okay, that brings us to the end of this episode. If you have any questions on what I've talked about today, please feel free to get in touch. You can DM me on my Instagram at Chemistry Made Simple. You can send me an email, matthew@chemistrymadesimple.net. And the best place, of course, is to come to my Patreon and ask in the community there. You'll find that at patreon.com/chemistrymadesimple. And thank you so much if you're already a Patreon supporter. I really appreciate that. Thank you for taking the time to listen to this episode. I hope it's been useful to you. And if it has, please consider supporting the podcast at our Patreon. And that's at patreon.com/chemistrymadesimple. Not only will you be supporting the podcast and seeing our updates, but there's also a community element to our Patreon, so you can connect with other students, and also you can ask questions or suggest topics for upcoming episodes too. Look forward to seeing you there, and also to speaking to you in the next episode. Until then, do look after yourself, and goodbye.